4:50 in the morning on April 22nd, 2026, the seismometers of the Bulusan Volcano network in Sorsogon province, Philippines, began registering earthquakes. Not one or two, a sustained, relentless sequence of volcano-tectonic events, one after another, all originating within 5 kilometers of the surface beneath the northern face of Bulusan's volcanic edifice. By 1:30 in the afternoon, in the space of just 8 hours and 40 minutes, the network had recorded 101 separate earthquakes. 101. Not in a week, not in a day and a night. In a single morning and early afternoon, while the people living in the surrounding communities of Sorsogon province were going about their lives, the rock beneath Bulusan's northern flank was fracturing again and again in a pattern that the Philippine Institute of Volcanology and Seismology, PHIVOLCS, recognized immediately and without ambiguity. They had seen this before, twice in 4 years. Both times they had seen it, the volcano erupted. PHIVOLCS issued its advisory the same afternoon. The language was careful and precise, the way that official volcanic bulletins always are, because the people who write them understand that every word will be read by local government officials, by emergency managers, by families deciding whether to stay or go. The agency said the increase in volcanic earthquake activity could indicate shallow hydrothermal processes beneath the volcano, which could lead to steam-driven or phreatic eruptions at any of its summit vents. At any of its summit vents, not at one specific location they could point to on a map. A phreatic eruption is not preceded by flowing lava or glowing vents or the dramatic visual signals that give people time to respond. It is preceded by what Bulusan has been showing for 6 weeks: seismic activity, ground swelling, gas emissions, rock fracturing underground. And then it happens, explosively, with almost no final warning at all. Bulusan Volcano stands at the southeastern end of the Bicol volcanic arc in the Philippines, at the tip of the Luzon island group that extends into the Philippine Sea. It is a stratovolcano, a composite cone built from successive eruptions of lava flows, pyroclastic material, and volcanic debris accumulated over hundreds of thousands of years. Its summit contains a 300-meter wide, 50-meter deep crater, and 3 additional small craters are located on its southeastern flank. The volcano rises to 1,565 meters above sea level, and its slopes are draped in rainforest that extends down to the rice paddies and communities of Sorsogon province below. Moderate explosive eruptions have been recorded at Bulusan since the mid-19th century. It is one of the most active volcanoes in the Philippines, a country that sits on the Pacific Ring of Fire and contains more active volcanoes than almost any other nation on Earth. The province of Sorsogon that surrounds Bulusan is home to approximately 800,000 people. The volcano is not an abstraction or a distant geological feature for the people who live here. It is the defining geographical fact of their province. Visible from their windows, shaping their weather, influencing their agriculture, present in their oral histories and their daily awareness, in the way that any powerful natural feature becomes part of the identity of the people who live beneath it. When PHIVOLCS raises an alert level at Bulusan, it is not raising an alert for a remote scientific monitoring station. It is raising an alert for 800,000 people, for local government officials, for the Bureau of Fire Protection and the Philippine Army and the Philippine National Police, for the disaster risk reduction and management councils that are now meeting and preparing and pre-positioning vehicles and personnel and food supplies and face masks for the ash that a Phreatic eruption would rain down on surrounding communities. The current period of unrest at Bulusan did not begin on April 22nd. That is when it intensified dramatically, but the warning signs have been accumulating for months. Ground deformation data from the continuous GPS and electronic tilt monitoring instruments deployed on the volcano began detecting something significant in the last week of January 2026. The western flank of the volcano started inflating, swelling upward, pushed from below by material accumulating in the shallow hydrothermal system beneath the edifice. That inflation signal on the western flank has now been running for 3 months without reversal. In the first week of March 2026, a second inflation signal appeared. This one on the southeastern flank, a different sector of the volcano beginning to swell. 2 separate flanks, inflating from different directions, converging on a central hydrothermal system that is being pressurized by something beneath it. On March 15th, 2026, the seismic sequence began. In the 7 days that followed, Bulusan's network recorded 435 volcanic earthquakes. By March 22nd, PHIVOLCS had seen enough. The agency raised the alert level from 0 normal, to level 1, described as low-level unrest with increased chances of phreatic eruptions. PHIVOLCS. Director Teresito Bacolco confirmed the decision publicly, citing the combined picture: 475 earthquakes in 7 days, flank inflation on both the western and southeastern sides, and sulfur dioxide emissions averaging 91 tons per day, below background levels, which is actually significant information in itself. Low SO2 in the context of increasing seismicity and ground inflation means the system is not freely degassing. The pressure that is building in the shallow hydrothermal system is not being released gradually through gas emissions. It is being retained, contained, building. The seismic pattern was also recognized for what it was, not just by the instruments, but by the volcanologists who have been watching this specific volcano most closely. That statement was made in late March. The 101 earthquakes of April 22nd arrived weeks later, showing that the system has not quieted and has not released its pressure and has not settled back toward baseline. It has continued. And in the early morning of April 22nd, it accelerated. To understand why a phreatic eruption is the specific hazard that PHIVOLCS and everyone monitoring Bulusan is focused on, you need to understand what a phreatic eruption actually is and why it is categorically different from the magmatic eruptions that most people associate with volcanoes. A magmatic eruption is driven by molten rock, magma rising from depth, degassing, fragmenting, and erupting as lava flows or pyroclastic material. Phreatic eruptions typically produce escalating warning signs: increasing seismicity, ground deformation, SO2 emissions rising sharply as magma approaches the surface and its dissolved gases exsolve. They are often, not always, but often, preceded by days or weeks of building signals that give monitoring agencies time to raise alert levels and communities time to evacuate. A phreatic eruption is driven not by magma itself, but by water, specifically by groundwater or hydrothermal fluid that encounters heat, either from a magmatic body beneath the volcano or from the naturally hot rock of an active volcanic system, and flashes to steam. At the temperatures and pressures found in the shallow hydrothermal system beneath Bulusan's summit, water exists as superheated liquid, held in the liquid phase only by the confining pressure of the rock above and around it. When something disturbs that confinement, when the rock fractures, when the sealing cap above the pressurized fluid cracks, when the pressure balance shifts, the superheated water flashes to steam instantaneously, expanding to roughly 1/700 times its liquid volume in a fraction of a second. That expansion is explosive. It does not produce lava. It produces a violent blast of steam, water, and whatever rock happens to be above the flash point, shattered, fragmented, and launched outward and upward at high velocity. At Bulusan, the June 5, 2022 phreatic eruption produced a gray ash plume that rose at least 1 kilometer above the summit and drifted westward. Ashfall was reported across multiple communities in Juban and Irosan municipalities. Residents described rumbling sounds and a sulfur odor before the eruption. The eruption lasted approximately 17 minutes. The April 28th to 29th, 2025 eruption followed a similar pattern, sporadic earthquake swarms preceding a steam-driven explosive event. In both cases, the earthquake sequences that preceded the eruptions looked, in the words of PHIVOLCS itself, similar in general characteristics to the seismicity now being observed in 2026. The 101 earthquakes of April 22nd did not arrive out of nowhere. They arrived as the latest escalation in a sequence that PHIVOLCS has explicitly compared to the pre-eruption sequences of both previous events. What makes phreatic eruptions particularly hazardous is not their typical scale. They are rarely the largest volcanic events a volcano is capable of producing, but their unpredictability and the specific nature of their hazards. A phreatic blast can launch ballistic projectiles, rock fragments propelled outward by the expanding steam, at velocities that make them lethal within a substantial radius of the vent. The specific weight and size of these projectiles depends on the geometry of the eruption and the characteristics of the rock being fragmented. But at Bulusan, pyroclastic density currents, ballistic projectiles, rockfall, and avalanches are all listed by PHIVOLCS among the potential hazards in the permanent danger zone. Beyond the immediate blast radius, ashfall is the primary hazard for the broader community. Volcanic ash that coats roofs, contaminates water supplies, damages crops, and poses respiratory health risks, particularly for vulnerable members of the community, including the elderly, pregnant women, infants, and those with underlying medical conditions. PHIVOLCS has specifically identified these groups in its community advisories, urging that special attention be paid to them in the event of an eruption. The permanent danger zone around Bulusan extends 4 kilometers in radius from the summit. Within this zone, entry is strictly prohibited, has been strictly prohibited since the alert level was raised to 1 on March 22nd. The extended danger zone, covering the southeastern sector specifically, extends an additional 2 kilometers beyond the PDZ and requires continuous vigilance rather than outright prohibition. Communities on the western side of the volcano, in the direction that previous eruptions have blown their ash plumes, have been specifically advised to prepare for ashfall. People living in valleys and along river and stream channels, particularly on the southeastern, southwestern, and northwestern sectors of the edifice, have been told to remain vigilant against sediment-laden stream flows and lahars, volcanic mudflows that form when ash and debris mix with heavy rainfall. The Philippines is a country of intense tropical rainfall, and the rain that falls on ash-covered slopes does not drain gently. It picks up the ash, the loose pyroclastic material, the destabilized soil, and it moves it downslope with devastating force through the valleys where people live and farm. Aviation has also been formally warned. PHIVOLCS has directed civil aviation authorities to instruct pilots to avoid flying near Bulusan's summit. Volcanic ash is one of the most dangerous materials a jet engine can ingest. It is essentially ground glass at the microscopic scale, and it melts inside turbine engines operating at high temperatures, coating turbine blades and potentially causing catastrophic engine failure. The aviation warning is not precautionary in a theoretical sense. It is precautionary in the practical sense that a phreatic eruption at Bulusan can produce an ash column with no advance notice for aircraft in the area to divert around. In response to the accumulating signals at Bulusan, the provincial government of Sorsogon convened its Provincial Disaster Risk Reduction and Management Council. Representatives of the Bureau of Fire Protection, the Philippine Army, the Philippine National Police, the local disaster risk reduction and management offices, and the social welfare and development offices all attended and all confirmed to the public that they have standby vehicles, personnel, and supplies ready to respond to a volcanic eruption. That response is genuine and it reflects hard-won institutional knowledge. The Philippines has one of the most experienced disaster risk reduction systems in Southeast Asia, built through decades of engagement with exactly the kind of natural hazard that Bulusan represents. The people of Sorsogon province have not been left to manage this alone. They have government agencies, emergency responders, and a monitoring system that is watching the volcano continuously and publishing updates the moment its parameters change. That monitoring system is worth understanding clearly because it is the mechanism through which early warning becomes possible. The Bulusan Volcano Network operates a suite of instruments across the volcano's flanks. Seismometers that detect the earthquakes produced by rock fracturing underground, GPS receivers that measure ground deformation at the centimeter scale, electronic tilt sensors that record changes in the slope of the volcano's surface as its flanks inflate or deflate, sulfur dioxide spectrometers that measure the gas emissions from the active vents, and cameras that provide visual monitoring when cloud cover permits. This network feeds data continuously to the Bulusan Volcano Observatory and to PHIVOLCS headquarters in Quezon City, where volcanologists analyze the combined picture around the clock. The 101 earthquakes of April 22nd were not discovered hours after they occurred. They were being tracked in real time from the first event at 4:50 in the morning, and the advisory was issued the same afternoon. But here is the honest reality about what monitoring systems can and cannot do in the context of phreatic eruptions, specifically. They can tell you that the system is pressurizing. They can tell you that the flanks are inflating. They can tell you that the earthquake rate is rising, that the pattern resembles pre-eruption sequences from 2022 and 2025, that shallow hydrothermal processes are underway beneath the summit. What they cannot tell you with precision is when the final equilibrium will be broken, when the pressure in the shallow system will exceed the confining strength of the rock above it, and the flash to steam will begin. That gap between knowing that an eruption is more likely and knowing when it will happen is the gap that phreatic eruptions live in. It is why PHIVOLCS says eruptions can occur at any moment, not as rhetorical emphasis, as the most accurate statement of the scientific reality. Bulusan does not exist in isolation in the volcanic landscape of the Philippines. Right now, simultaneously, 3 other Philippine volcanoes are in elevated states of activity. Mount Volcano in Albay Province, 70 kilometers northwest of Bulusan, and arguably the most famous volcano in the Philippines for its near-perfect conical profile, has been at alert level 3 since January 6, 2026, indicating a relatively high unrest level with potential for hazardous eruptions. Canlaon Volcano on Negros Island is at alert level 2, with ongoing eruptive activity including daily ash emissions rising 350 to 1,100 meters above its summit, sulfur dioxide emissions ranging from 680 to 2,313 tons per day, vastly higher than Bulusan's 75 tons, and 12 to 53 daily volcanic earthquakes, including periods of continuous tremor. Taal Volcano in Batangas Province has maintained Alert Level 1 continuously since July 11, 2022. Nearly 4 years of sustained low-level unrest. The Philippines is not experiencing a single isolated volcanic event at Bulusan. It is experiencing a volcanic system in which 4 of its most active volcanoes are simultaneously in elevated states, a situation that reflects the deep tectonic reality of the Philippine archipelago. A nation built on and surrounded by subduction zones where the Philippine Sea Plate and the Eurasian Plate and the Indo-Australian Plate converge, generating the magmatic and hydrothermal activity that has built these islands over millions of years, and that will continue to drive their volcanic systems for millions more. The people who live in Sorsogon province are not strangers to this reality. They live with it. They have lived with it through the June 2022 eruption, through the April 2025 eruption, through every alert level change and every seismic swarm and every advisory that PHIVOLCS has issued about the volcano that defines the landscape of their home. The Sorsogon province. Disaster Risk Reduction and Management Council has met. The face masks are stockpiled. The ambulances are on standby. The Army and the Police and the Fire Protection Bureau have confirmed their readiness. And the Bulusan Volcano Network is watching, seismometer by seismometer, tiltmeter by tiltmeter, as the rock beneath the northern flank of the volcano continues to fracture, as the western and southeastern flanks continue to hold their inflation without reversal, as the pressure in the shallow hydrothermal system builds toward whatever threshold the geology beneath Bulusan will eventually decide to set. As of today, April 27, 2026, the alert level at Bulusan remains at 1. The entry into the 4-kilometer permanent danger zone remains strictly prohibited. The monitoring continues. The advisory warnings stand. And in the communities downwind of the summit, people are watching the sky above their volcano and preparing in the practical ways that communities in this part of the world learn to prepare for the morning when they will wake up to the sound that preceded the eruptions of 2022 and 2025. The rumbling, the sulfur in the air, the gray ash column rising from the summit and moving in the direction of the wind. Bulusan has done this before. It has done it within memory, within the living experience of the people of Sorsogon province. It will do it again. The seismic sequence of April 22nd tells us the system is not settling. The inflation signals on the western and southeastern flanks tell us the pressure is still being applied. The 101 earthquakes in 8 hours and 40 minutes tell us that the rock is still fracturing, still accommodating the stress that is building in the hydrothermal system below. The volcano is not dormant, it is not stable. It is, in the careful measured language of PHIVOLCS, on the edge of something, and the people who live in the shadow of that edge are doing what they have always done, preparing, watching, and waiting. If this kind of storytelling, the real science, the real people, the real hazard, told without softening the parts that are hard, is what brought you here, please subscribe. I will see you in the next one. Share content. Hey everyone, geophysicist Safe and Burns here. There's just been a violent volcanic explosion in Japan. This is Sakurima Volcano, Japan's most active volcano located in the southwest part of the island nation. And this has sent ash everywhere. There's ash now raining down across the prefecture. Then Pasted Wolf Creek Dam in Kentucky is leaking, and not just a little bit. This earthen structure, holding back 722 billion gallons of water, has been hemorrhaging through its limestone foundation since 1968. The U.S. Army Corps of Engineers classified it as high risk for failure, requiring emergency measures to Pasted. Right now, 300 miles off the coast of Oregon, a sleeping giant is reaching its pressure limit. A mountain-sized underwater volcano monitored for a decade is 94% full of magma. And just days ago, a swarm of 18 earthquakes shook the seabed in the same tectonic system that feeds it. What's happening in Pasted, the ocean floor off Washington state, is tearing itself apart right now. And the machinery doing the tearing is the same machinery that is slowly loading the most dangerous fault in North America, with enough energy to level every major city on the Pacific coast. 18 earthquakes in 12 hours. The first Pasted